makes it so that you can like be looking down reading a script, but it changes it so that you're looking up at the command.
I'll see.
It's pretty a simple thing. But
What, so you're looking there?
Like you'd be looking here, and then it makes it so that it makes it look like you're really good. Really good.
Well, I already multitask with video games. So like my wife and I sit and watch shows on our living room with big screen. And then I sit in my massage chair and I have these AR glasses that will project the screen on the ceiling. So I use a Steam Deck and I play like Final Fantasy 14 on like 100-inch screen on my ceiling. But I could see underneath it and see the TV.
Yeah.
It's awesome. No. Actually, the epic way of doing that was Allen in the Ocean, this cruise I just did. At night, where it's just, I mean, you're in the middle of the Pacific, no lights anywhere, right? And just on the backdrop of the stars, projecting the whole game projected across the entire sky. It's pretty sweet.
Better with those clouds?
I don't think so. I don't think it would have made a difference when it's that dark. Okay, did we start writing any of this yet? Oh, we were looking at strings and stuff, right? Oh, then I threatened a quiz, but we already burned too much time. No, screw it. Did you guys all study?
I did.
All right, good. Well, good. So you learned the stuff.
Yeah.
All right. So we talked about strings. Did I do anything with strings? I don't see any code here. Did I write any code?
You put it in Slack.
Oh, well, let's just start over. Because I want to show you some cool stuff with strings that are going to be a little misleading. But
I did have one question. So, if I remember correctly, you said that only strings could be made with that syntax.
Yep.
It let me make an integer with that syntax and didn't complain.
Oh, I'm sorry. That's true because those are primitive types, but those are actual primitive types. So when you said integer I equals 5, it built an int I. It still built that for you. It then probably gave you access to the integer class methods as well, but that is more of a syntactic sugar thing than an actual difference thing. I'm going to show you an actual difference thing here.
Okay.
So everybody can see everything. All right, so string s equals hello, string s2 is equal to hello, string s3 is equal to new string hello. Okay, and if I remember last time, I kind of showed you that, talked about that toString method. We like quickly showed how the object class, which is this top level object in all object-oriented languages. Every object-oriented language, when you take 470, we build an object-oriented language, you see that we have to start with like this core piece that everything builds off of. So the top level generic object in Java is called object with a capital O, and inside of it, it has a method called toString. And toString, the default toString, if you don't teach it to do anything extra, prints out the memory address of the element. So that's why when we created like a blank player or something like that, we're able to get the memory addresses because we didn't invent a new way of doing it. So that's how we can create arrays. Arrays are based off of generic objects. So therefore they get the generic toString, which shows the memory address. So that's how we prove to ourselves that pointers exist. We just don't have the syntax to manipulate them. Now, typically, if we do a println on something, we probably want some real output as opposed to just a memory addressy thing. But the memory addressy thing exists to make println work on anything that's an object. Okay, and if I actually show that to you real quick, have the Java documentation still open somewhere? Yeah, this is good. So I'm going to go to the system class because you've seen system.out.println, and we'll talk more about this. But if I go to the system class and I go to one of its fields called out, which is a print stream. And then so a print stream has then a function called println down here. And we see that it has a zillion different printlns. One that knows how to print a Boolean, knows how to print a char array, a double, a float, an int, a long, a string, as well as an object. So when it prints an object, what does println do? It calls that object's toString method. That's what it does. Because it knows it exists. Because when the Java people, Sun Microsystems, when they wrote the object class, one of the small number of things they put in there was a single method called toString. So every other class in the entire language can assume that every single object at some level in its lineage will have a method called toString. And that's what this println calls. All right. So now let's try to trick you. All right, so I have a couple different strings here, right? Let's give us a fourth one. S4 is equal to new string. Hello. Okay, so here's another thing that a lot of textbooks will lie to you about or overlook when it comes to strings. So I'm going to print some stuff out, system.out.println s equal s2. Okay, just like in C++, double equal sign is the test for equivalence, right? Okay, I'm going to throw a little twist in here. I'm going to say it's the primitive test for equivalence. I think we mentioned that last semester as well. It's for comparing primitive types. All right, so is S equal to S2? They are, okay, so we expect this to give us a true, right? And it does, gives us a true. So there's our true. All right. What about S equal to S3? So now we start getting concerned. Go ahead. Well, the new keyword is how we create any new object. We did that a little bit ago when we created our players. We did it last semester. Every single time we created an instance, one of our objects, we had the new keyword. Like last semester, we would have had like player P is equal to new. The string class already exists in Java. This is not something we wrote. This is built into the language. These are strings, just like last semester in C++, we had strings. But I'm telling you, you're rarely going to ever build a string this way. You're going to typically use the special syntax for strings like this. And we're about to show, though, that there is a difference. All right. So S equal S3. What do we think? Less confident in this one? Well, why? Isn't hello equal to hello? Go ahead. So there's our false for that guy. All right, so what about S3 equal to S4? Maybe if they come from if they're built the same way. No, also going to be false. Yep, also false. All right, but why did S equal S2? So this is something that a lot of programmers will run into at some point because it's not uncommon. So first of all, we almost always build our strings this way. I've mentioned several times that Java is a string-based language, and part of that means that Java has given us this nice little syntax for conveniently building strings. But what they do is they throw you into this running wood chipper of all these little exceptions, like, well, strings are objects, but sometimes they don't behave like normal objects. So S equal to S2 came out as true. Question is why? Go ahead.
Is it creating something that doesn't have like an accessible memory address?
Okay, well, why does this make you question the memory address? You're on a good track, but I want to make sure that you're on a good track based on reality, not guessing.
Because the other ones were printing out memory addresses.
No, they won't. If I print out S3, even though he was built with the new keyword, he prints out hello. I think we showed this last time. The string class has their own toString method that instead of doing the memory addressy thingy, it does the contents of the string thingy. Go ahead. But aren't both of these guys on same virtual machine? Let's think about what happens. And it's related a little bit to what you said. Let me just jump up here to, let's create a little slide for strings here. String class. Using new keyword versus the special string syntax. All right. So in Java, there are two, there's actually probably more than two, but let's just keep it generic here. There are two memory locations. There is literal memory, and then there is user requested memory. This is whenever we use the new keyword. So whenever we use that new keyword, this is user requested memory. We're saying, go find me new memory. Okay. As opposed to literal memory, like if we say int I equals 7, that's going to, that is, I is the integer literal 7. That's what it holds. All right. So it's going to have, now, how many times, I mean, does 7 ever change? Or is 7 kind of like this hard-coded thing? Do you think it needs to store the number 7 multiple times? Or once 7 has entered literal space, anything that is a 7 can just use that same memory location? That kind of makes some sense. All right. So let's draw some pictures here. Hide this guy. I know, it's so, I'm just gifted. It's just, I mean, really, I can't even explain it. It's so good. All right, so if we say string s is equal to hello, and we say string s2 is equal to hello. The very first time, actually, I want to do this in two separate boxes. When I say string s equals hello, we have this literal memory, we're going to say. See, here's what this is where the ninja skills come in. Watch this. We got to go there and there. Boom. Literal memory. All right. And what it does is it goes and looks in literal memory and says, oh, is there already a hello in there? There's not, right? We don't have hello in there. So we're going to go ahead and we're going to give ourselves this, just felt like it needed to capitalize it on me. We're going to say, let's do 0, A, B, C, 1, 2, 3 is equal to hello. I invented that memory address, but you're supposed to believe that's a memory address. All right. So it goes ahead and creates that thing up there. So this string s points at that guy. All right. Now we create a string s2. Also equal to hello, using this syntax. Using the syntax where we do not use the new keyword. The new keyword is whenever we want memory. Okay. So it's going to say, oh, you're looking for a string s2. Hello is a string literal. It's going to look in literal memory and says, do we already have the string hello? We do. So since we already have the string hello, it's not going to create it a second time. It's just going to make s2 point at that same memory address. So then what ends up happening here is when I say S equal to S2 to the uninformed or the Python programmer. Okay, and this, well, no, I mean, I wasn't like a burn. It's because I mentioned, hopefully you saw my post, Emily's post in Slack the other day that I added something onto. But even though I teach this idea that programming is a skill set, the language doesn't matter. Each language does have some little nuances to it, and that's what differentiates things. And when I said that, unless you're a Python programmer, in Python, the double equal sign is overridden to apply to strings to compare the contents of those strings. But in C++, C++, Java, C#, all these languages where, especially Java and C#, let's say, where strings are 100% objects. C objects didn't exist, so there's a little bit of a weirdness there. But the double equal sign, I mentioned a little bit ago, this is the primitive equivalence operator. It's used for checking to see if one primitive is equal to another primitive. And what are our primitive types? Byte, short, int, long, float, double, char, Boolean. There's one magical hidden one, pointer. All right. So when I say S equal to S2 to the uninformed, we think, oh, it's checking to see if hello is the same as hello. It's not. It's saying, does this variable S live in the same place in memory as S2? If we look at our picture here, they do. They are both at memory address 0xabc123. It's comparing the primitive pointers of those two objects. That makes sense? That's why it's true. 0xabc123 for this guy is equal to 0xabc123 for this guy. That's why it's true. Make sense? Punchline is, don't use the double equal sign to compare strings. If you want to compare strings, system.out.println s.equals s2. System.out, misspelled it. Print. Then. And actually, this doesn't really prove it to you because you get two trues. But if we change this to S3 and S4, or S3 and S1, whatever, and then we change this to S3, and we change this to S4, now we'll get a false, because those are not the same pointer, but we'll get a true on these guys because they hold the same contents. All right, so in Java, if you want to check to see if one string is equivalent to another string in terms of its string contents, you use the equals method of the string class. Go ahead.
If I'm out of string, like S, that bucket's 0, share it to a char, and then just the bucket percent.
Well, a string would never be equal to a char.
Or point, that's right. Like a single bracket.
An array?
Single quotation.
Oh, yeah, okay, single, that's a char. Yeah, so strings and chars would never be equal to each other. Before I go here, what's up? It's not. It's not different. But the difference for us is in C++, we did not commonly have the ability to create strings two different ways. We actually could have, we just didn't see it. Because strings are objects in C++. But I'm showing you this. You will hardly ever see a string built this way. It just, Java will just build strings all day long using this. I just want to drive this point forward that strings are objects like any other object, and literally every single other object, when you create an instance, you're going to build it using a syntax that looks like this with the new keyword. Strings are that one exception. And go ahead. Let me draw the picture for that side. So Now we have our, what did I say? Call it user requested memory. Call that user requested memory. So now we'll have string S3 is equal to new string hello. And because we say new, that's our real estate agent. We're asking the operating system or the memory manager for the Java virtual machine in this case to go out and get it some memory. All right. We want memory big enough to hold this string. So it's going to be X, Y, Z. Oh, two X's. That's not going to work. Actually, it's not hexadecimal, is it? DEF 789. All right, that's what that guy points to. And then when we create our string S4 and say new string hello, again, we're asking for new. We want new memory. So this is going to give us, call this guy ABC 789. So now when we say S3 equal S4, DEF 789 is not the same thing as ABC 789. Those are different memory addresses. That's why that's false. Let's just do S equal to S2. So ultimately, this is the fake out thing that stumbles a lot of programmers. A lot of programmers will look at this and they will expect both of these to print out true because they think the double equal sign is comparing the contents, the hellos. S equal to S2 is true because of this. They were built not using the new keyword. It's all, the double equal sign is the primitive equivalence operator. It's checking memory. It's checking primitive types. Then the second one, S3 equal to S4, is false for this reason. S3 has its memory location because we requested new memory. S4 has its memory location because we requested new memory. They are not the same memory. That's why they're false. That's why we get true and then false for this. And that's where a beginning programmer or an uninformed programmer, let's say, who hasn't really thought about that under the hood memory thing, looks at this and says, what the heck is going on? Go ahead. No, dot equals is the equals method is a method that's in the string class. I have it up here, right? I think I can just back ninja a couple times, right? There we go. No, it's a method of the string class. Here's equals. So equals compares this string to the specified object, specifically to the toString result of that object. So that's a string method that allows, forget about the word object here. Typically, if we're using that, we're comparing strings to other strings. So really a string knows how to compare itself to another string. And when we do that, probably what we meant is the contents, right? We probably are not really even interested in whether or not they share the same memory address. From a modern day programmer's perspective, we could care less that we're wasting some extra memory over here. We're probably going to write our strings this way just because it seems cleaner, seems easier. We're using strings all the time. Why use the new keyword if I don't have to? Okay, but that comes with a consequence, right? So this under the hood idea of it is the important part. Imagine having to trace down that bug, especially when you're 1,000 lines into your program and you made this assumption, maybe coming from a Python programmer's background, and you made this assumption, and strings can compare themselves in terms of contents using the double equal sign. Make sense? All right, so those nuances between languages are important, but always make sure when you when it's the first time you're messing with a certain thing, you're like, okay, I'm comparing strings. This is a good example for any language. Comparing strings is something you're probably going to do fairly often, right? So you might say, okay, let's just make sure strings work the way I think they're going to work. As far as I can consider, I think that these are the only two ways strings might work in a language. All right. You just kind of want to know, based on the syntax, how does the double equal sign function? Is the double equal sign looking at the contents, or is it looking at the pointers? Now, you might say that in Java, they could have just made it look at the contents, like Python. Since Java removes the syntax for us to even manipulate pointers, do we actually care if we're dealing with strings? Probably not. So we don't really care whether we have 2 memory buckets or 1 memory bucket here. It's above our pay grade. Yeah. Well, if you're going to compare strings in Java, use dot equals. That's just, if you're going to compare the contents of strings, you're going to use dot equals. Or you could write your own method for comparing the contents. Go through and just compare char to char and count the number of ones that don't equal each other, because chars are primitive types. So we can use double equal sign when we compare one char to another char. That makes sense? Was that what you were asking before? Yeah. Yeah. The s.char at 0 is a char. That's a primitive type, just like it was in C++. And double equal sign for primitive types works all day long. It's looking at the contents because they are basic, built into the language types that only can hold a value. And typically when we're dealing with primitive types, memory is out of the, we don't think about pointers. Although in C and C++, because we have the special syntax, we can think about pointers in there, even though I would say most programmers never do. We just make that assumption that all primitive types are small in terms of memory footprint. So we're not going to really go out of our way to care that much about whether or not we're passing a long by value versus a long by address. Because technically a long value is probably technically a larger value than the address of long. Whereas a byte, or a char is probably even the better example. A char in C++ was 8 bits. In Java, it's 16 bits. And we'll talk about that, but it's ASCII versus Unicode. But still, if we think about our 64-bit operating systems, a memory address is 64 bits big. The biggest a char is, so in Java, it's 16 bits. So it would always be lighter to pass actual char values around than it would be to pass memory addresses which point at chars. 16 is less than 64, right? But if we're dealing with longs, we're going to say that 64 is less than 128. But 128 bits is like nothing, especially by today's memory standards. When you have 16, 32 gigs, 64 gigs, whatever, 128 gigs, right? 256 now. Oh, wonderful. I mean, he's complaining that I'm blowing money on art. He would never use his computer. Everybody uses cloud computing for that now. Screw it. You have basically infinite memory in the cloud. Yeah, he never uses 256. He'd have to write some program specifically with the goal. Yeah, and you even have to try for that. Yeah. So if any of you are going out and buying computers, 16 gigabytes is plenty. If you're buying a Mac, maybe spring for the 32 gigabytes if you're able to in that machine. Macs tend to get a little bit more life, but they're also not upgradable. So if your computer is not upgradable, you got to buy all the memory you think you're going to need for its lifetime up front. So I'd probably nod towards 32 for a Mac. But that's going to last you longer than the Mac's going to last you. The only argument that you would get more resources like I have on this is if you're going to run a lot of virtual machines. Because then every time you launch a virtual machine, my Windows is using 16 gigabytes of memory and 4 cores on here. And, so I'm subdividing those resources up among 4 different operating systems or something potentially at once, even though I typically don't run more than 2. Yeah, I mean, I buy the machine because I use I used to use Boot Camp years and years and years ago, but who wants to reboot your computer just to launch into a different OS? When I just have tons of resources, I can just launch 2, 3, 4 OSs at once, no problem.
That's why I can run my RAM. I can get away from OS.
That's it. That's it. So I mean, you can go through, you can put in the effort and make it happen. Okay, but a normal user is never going to like require that, even under the most power user things. And I think I mentioned it a couple classes ago, the biggest mistake gamers make is they go and get too many cores and too much RAM, and they end up getting individual cores that are slower than the maximum core speed they could get if they did like a quad core or a 6 core. So technically your gaming performance is actually less, even though they have 96 cores. You'd rather have, if you're drag racing, you want the one big engine that's going to fire you down that road, instead of having, 32, brushless electric motors that get you up to a top speed at a certain time, but, you don't need a parachute to slow down. All right. Questions about this memory crap? Make pretty good sense? Now, so pointers still do exist, right? Just clarifying, exist in Java, so don't buy any of those lying books. The Deitel books are pretty good. If you're looking for like a Java reference book, I think it's DEITL, might be TEL. But the latest version, they come out with a new version every year, probably version 300 now or something. They're good, but you can buy the new version for $78, or you can buy 3 versions ago for $8 used or something. Get that one. In fact, I think you can go back to maybe version 6 or 7. They've open sourced it. You can just find the PDF legally for free. Came up with a freight company. See what Deitel do. DEITEL. Deitel.com. Oh, looks like 11th edition is the current one. Yeah, look like the 9th or 8th edition. Java's been Java. Sure, they've added a couple of little things, but these are on the outskirts of Java. I don't think things have drastically changed very much. And if you want a good book with some good examples in it and stuff like that, the Deitel books are pretty solid. And if you can get it for free or for $5 and you like a physical resource, that's probably worth it. Okay, now getting back to this, let's assume that we have something like that. S3, S4, we have HELLO, but one's capitalized. So if I say, well, obviously S3 equal to S4 is going to be false, right? For the memory address reason. S3 dot equals S4 is also going to be false because they technically are not exactly equivalent content. And H capitalized is different than a H lowercase. And that comes down to like how you were asking. And I said, well, if you want to write your own equals method, you can come down here and you can say public Boolean, I don't know, compare strings, string S2, something like that. Technically, you probably might want to ask and say, if S dot length is not equal to S2 dot length, don't waste your time and just return false. All right. If they're not the same length, they're not the same string, right? Else, You just might have a loop where int I is equal to 0, I is less than s dot length, I plus plus. It's looking pretty similar to C++ here. All right. And then we just ask the question, if now the way you would have gotten a character in at a certain bucket in C++ would have been s at bucket 0 is equal, let's see, it's not equal to s2 at bucket 0. Then we would return false. And if we survive this, we'd return true. That's how we would compare them in C++. Now, I just want to check something here real quick. That's a pretty common language syntax in other languages now. I just want to see if Java happens to have added it. This would have been a syntax error historically. Let's just see if it still is. Cannot find symbol, compare strings with Boolean. No. Oh, it's not S3 dot. It's just compare strings. I'm not calling it correctly. Compare strings expects me to send it 2 strings, and there we go. This is actually a little bit sketch how I've written it. I just don't want to set up a bad precedent. We'll talk about why I did this later. Don't worry about this. This is when we talk about functions. All right, so compare strings takes in 2 strings. Yeah, it requires an array if you want to use that syntax. So Java doesn't let you access individual buckets of a string using the square brackets like you can in C++. Instead, you use a function called char at. Get me the char at bucket I. Get me the char at bucket I. Yeah, capital A. And you can see that if you go to the documentation under string, scroll up here. Where's our char at? There's char at, takes in an index, and it returns the char that is at that specified index. So when it's 0, this will return for us here a lowercase h for one of them and an uppercase h for the other one. And we're comparing lowercase h to uppercase h, not the same char. Go ahead. Like, why did I do this? Because I want to potentially check every single character in the strings. If there's 5 characters, I want to make sure the first character is the same, the second character is the same, third character is the same, so on and so forth. So that's why I goes on this voyage from 0 to 4 in our current example. And each time through, we check the character that lives at that place to the character that lives at that same place in the other string. And if they happen to not be equal to each other, that means we found a difference between those strings, so we'll return false. Make sense? All right, so this guy should give us a false because S3 is not equal to S4. Go ahead.
Isn't it fairly redundant to put that inside the else statement?
Put what inside the else?
The main purpose gets false and so it is false initially this time there.
Well, you're right. I mean, this just did the quick test of not having to spin through 99% of the string. Yeah, that's true. Yeah, what he's saying is because return immediately makes a method or a function end, the only way I even get to line 31 is if this function's still running after this. So I technically don't need the else. I can just have the code there. I would say the else is fine. Probably reads better. If this is true, return false. Otherwise, let's look at something else. But you're right. Yeah, I don't actually know if it'd be a performance difference under the hood, but you're right. The else is not required. All right, so this comes out as false, our compare strings, because bucket 0, a lowercase h is different than an uppercase h, right? Well, what if we want to have a compare strings, ignore case? All right. Well, then what we need to do is we need to make sure that both of those strings are either both capitalized or both lowercase before we even start doing anything, right? So we could say S is equal to S dot two uppercase, or you can do two lowercase. S2 is equal to S2 dot two uppercase. And those are functions inside of strings. And we'll talk about why I call these using the instances and this using the name of the class. That'll be kind of our next thing we're going to talk about. All right. So now I convert both of them to uppercase before I even start checking. Now I don't have that problem of lowercase h compared to uppercase h. So now I get a true out of that guy. Now they are equal to each other. But there is also a equals ignore case built into strings. So you can compare two strings ignoring case sensitivity if you'd like. And that's a function that you don't have to write. It comes with the string class. So there's our other true. Go ahead.
So I've been a lot of JavaScript, a lot of the same thing. Is there like a similarity?
Well, Java and JavaScript are not related in any way. The fact that they both have the word Java in it is insignificant. Yeah, and that's common in a lot of, I mean, Python has a two, I think it's called two upper in Python. Yeah, I mean, most languages have some way of manipulating strings to get everything in uppercase, everything in lowercase, remove a certain thing, reverse a certain thing. Some of them have that kind of junk. All right, I want to show you one more thing real quick, and then I'll take your system.out.println S concatenated with S2 is going to give me hello followed by hello. With no space. Hello followed by hello. If I want to get a space in there, so this is the same concatenation operator we saw last semester. So I'm going to put the char version of a space in there. I'm very purposely putting a char version of a space in there so I can give you your homework assignment. All right. So you can concatenate chars onto strings. Maybe you want to start with an empty string like last semester. Hint, hint. All right. So now I'll get my little space in there. All right. So let's just give ourselves a little quick Java practice for homework. Write a Java program that, and you could just do it all in main right now if you want, that sets two, because we're going to be talking about methods next, the difference between static and non-static. Write a Java program that sets two string variables to strings of your choosing. Your program should reverse both of those strings and then concatenate them together with a space in the middle and print the result. You may only use the functions we have introduced in class. I don't think the string class itself has a reverse, but I'm sure there's some built-in reverse thing. I want you to write a for loop that reverses these, right? And uses concatenation to glue them together. Yeah, take a string, if it's hello, reverse it, so it's hello backwards. And then the other string is elephant, reverse it, so it's elephant backwards, and then print them out with a space in between them. All right, so. I just want you to concatenate and do the things twice based on different lengths, potentially different lengths. If you want to write a function that does it, which is where we're going next, you can do that as well. All right. Submit the self evaluation from Slack and a link to your code. If you are using online GDB to get a link at the end, just hit save. I guess I'm saving it in there. And once it's saved, then you can hit share and just copy this link. That will give you a link to that code, and that's frozen in time. So even if you make changes to that code after that, I'll still get the version that you submitted. Okay? Only when you share again will you get a brand new link. All right, so I'll give you this current link in Slack for now so you have some reference. I'll put the assignment up on Blackboard. It's due on Wednesday. Questions, comments, concerns, bribes? Taco Cat? Oh, it goes back. That's fine as long as your logic's right.
No, that would be annoying to try and see if it works.
I'm pretty decent at reading